We're always eager to look at motherboards where subscribers are asking questions. Today, the ASUS Maximus Z690 Extreme that has Thunderbolt 4 on it. A lot of information we're going to go through because this is in response to some questions we've had, which got kind of long, from Richard Dow. And what I'm going to do, I'm not going to read the question, but I'll have it up as a link in the description. What I'm going to do is go through the points that I've itemized to condense this so we can spend more time because there's a lot of information he's asked. So I'm going to have roughly 12 talking points that we're going to go through of his questions to keep this tight as it relates to that motherboard, because some of the information goes off a little bit, but it's all relevant to the motherboard. Question number 1, following PCI Express resources. Okay, what we're going to have to do as we go through this, I'll read the first question, but we've got 3 things we've got to look at. We've got to look at the motherboard, the processor, and the chipset, and go through how those resources are laid out. So question number 1, and I've got a quick question for you guys. When you're looking at a motherboard, can you list the 5 top items that you're looking at? Are you looking at what? PCI Express resources? Probably not. Are you looking at slots? Probably. Are you looking at M.2 NVMe connectors? Hopefully so. Well, we have to remember and keep some of these things in mind because this is going to be relevant to what we're going to talk about. We're looking at a desktop motherboard. There's been the high-end desktop, which is what I have in front of me, which is the Gigabyte TRX 40 Designaire, which has gone flat, unfortunately. Sorry to know about that. And then the next level up is a workstation. So there's going to be some themes that are going to be recurring in this information, where some of this information should come together, but some of it's diametrically opposed. And I'll relate that and share with you my thoughts on all that. And of course, the next level from a workstation would be a server. And then you get into enterprise and stuff like that. Okay, there's a lot of fascinating technologies going on right now. Most of it I'm a fan of. Some of it I'm not a fan of based on implementation. We're going to see some of that. But the question number 1, following PCI Express resources. Question, 2 GPUs and 1 M.2 NVMe PCI Express 5.0 drive. Is that doable? No, that's the short answer. The longer answer, we got to go look at those other 3 items. What you're going to get into, because of those 3 resources, you can only use 2, so you have to pick 2. Now, you've already defined 2 based on one of the other questions we're going to go through, but I want everyone to understand how this all works. So we've got to look at the motherboard, we've got to look at the CPU, because some of this stuff is going to go back and forth, and we've got to look at the chipset, and you'll see how those details matter. First, we'll go to the ASUS ROG Maximus Z690 Extreme page. Next thing we need to do, we've got to go over here to Tech Specs, and what we want to do, because we're also going to go to the manual, we'll download that, but we're looking for consistent information where we can see some information repeated so we have a body of information, because of all the stuff we do looking at, there are some things that are not real clear. ASUS has always had the best documentation. However, at the present, some of that stuff is getting a little bit obscure, and some of the information, no matter what we share, the bottom line is what's in the BIOS, because what's in the BIOS is the only thing that matters. And some things are referenced here in the documentation that are not in the manual. We're going to have 2 manuals we're going to take a look at, but let's start first with the tech specs. Okay, the CPU, we're going to verify that as we go through it. The memory, also relevant, 4 DIMMs. Most relevant, this question is going to come up twice. Non-ECC only, and this is dual channel memory architecture. I'll come back and reference that as well a little bit later. As far as graphics, there are 2 Thunderbolt 4 ports. And those are USB-C, keep that in mind. There are some oddities on this motherboard we're going to get into. Expansion slots. And this is usually where most of our questions start. Okay, there are 2 PCI Express 5.0 by 16 slots. That's 1 slot mechanically and electrically by 16, or 2 slots by 8 electrically. We have 2 stars, we're going to reference that in just a second, because this gets a little bit confusing. And on through the chipset, we have 1 PCI Express 3.0 by 1 slot. Now, bifurcation table. This is the only reference I can find about the bifurcation table, and it's referencing a bifurcation table as it relates to a quad card, which is ASUS's version of a 4-drive M.2 NVMe PCI Express drive card, where you can put 4 drives on 1 16-lane slot, but it requires 16 lanes electrically for you to see 4 drive, because each drive has to have 4 lanes. So 4 by 4 is 16. Okay, this bifurcation table that's referenced The only thing that, as I mentioned about the BIOS, is what matters. You're going to look in the BIOS and see how that's set up, because my expectation is, I'll come back and get into the details, is you're only going to see 2 drives based on the bifurcation table. But you're not asking about putting a quad card in, but you're going to reference it in one of the other questions where you're only going to see 2 drives as far as I can tell by my research. But that's one of the other items to point out. There's lots to point out. This motherboard has some pretty wild and crazy stuff on it, and I had to go through it several times to get the gist of where everything is, and I'll show you as we get into it. Okay, for the 2 stars, M.2_1 shares bandwidth with PCI Express with 16_2. We're going to look at the manual and see where that's all laid out. When M.2_1 is enabled, PCI Express with 16_2 will be disabled. So to reiterate, 3 resources, 2 slots, 1 M.2 connector. You can use the combination of 2, but you cannot use all 3 simultaneously. That's what you get into on a desktop motherboard that has shared resources. When you get into a high-end desktop like we have here, you still have some limitations, but you have dedicated resources. Where you really get into full-blown dedicated resources, and there's still some stuff that's shared, is when you get into a workstation. Some recurring themes. Next star. And with 3 stars, this also supports Intel Optane, which is a type of persistent memory through the PCH, which is the platform controller hub, which to reference is through the chipset. And supports the NVIDIA bridging technology, which used to be SLI, which is now referred to as NVLink. And for storage, this motherboard supports 5 M.2 NVMe connectors and 6 SATA ports. And we've got another star to work with. Okay, to reiterate, M.2_1, M.2_2, both of those are to the CPU. The primary M.2_1, PCI Express 5.0, 4 lanes. M.2_2 is PCI Express 4.0, to reiterate, 4 lanes, as required. And then through the chipset are the other 3, which is M.2_3, PCI Express 4.0, 4 lanes, and it'll also support SATA drives. But we focus on the M.2 NVMe PCI Express drives. And then you have the DIMM.2_1 and DIMM.2_2. And both of those on that card will be PCI Express 4.0. Good to know. But remember, those are all through the chipset. And then we have 6 SATA ports. Now, the Intel RST for NVMe RAID will support 0, 1, and 5. SATA RAID will support 0, 1, 5, and 1, 0. We're going to need to do a separate video about RAID for basics and beginners. But right now, I'm only going to address RAID as it relates to the RAID that is supported on this motherboard. So as it relates to RAID, RAID 0 and RAID 1 have the same requirements, 2 drives. When you go to RAID 5, the requirement's going to be 4 drives. That's relevant. Now, you're not going to do RAID on your NVMe as we get into this. What you want is RAID on your SATA. Even though you got 6 SATA ports, to reiterate, you can only put 4 of those, which is what you'll need for RAID. Why? And we've also got Intel RST for the Optane on the M.2 slots as appropriate. Okay. M.2_1, we know about bandwidth being shared, so 3 resources, only 2 can be used. And here's the deal on the SATA ports. RAID configuration and boot drives are not supported on the SATA 6G_E1, E2. And to reiterate why? Okay, you got 6 SATA ports, but you got 4 that are native chipset support. What does that mean? Those other 2 are on a separate chipset, and because they're on a separate chipset, a chipset by definition means that it's going to have a driver. A driver by definition means it's going to have an operating system. So therefore, you will not RAID those, and you cannot use those as boot drives, but you can use those once you're in the operating system. So you got 4 drives on SATA that you can put in RAID. One of the big benefits of RAID 5 is supposed to be hot swap, but that was not one of your requirements to be able to use hot swap. And by the case you're using, another thing that's going to come up, and we get into this a lot of times, is it going to be function or form? And those are somewhat diametrically opposed, and you're trying to bring those 2 together. And I'll give you my thoughts once we get through all this on a lot of information that you're asking about. Because when I go through these specs, depending on the question someone's asking, I try to keep that relevant, but sometimes I'll get off on other stuff as it relates to that motherboard without going down a rabbit hole. Okay, as we get into this, because there's a lot of information here going on, I think this is relevant for everybody to think about. Not everybody is going to agree with what I say, but what we try to do is look at what we have reference on and how we reference that to what we have a perception and perspective of. And we hope that what we're sharing with you will help give you some more insight, whether you've thought about these things or not. Like I asked in the beginning, what are your 5 requirements? Write those down and look at that and see how that motherboard compares with what you think you want. Because once you understand how to look at your PCI Express resources, once you understand what you're looking at, which right now looks like, oh, I didn't think about that, but once you see it, it's like once you see it, you can't forget it. ECC is one thing that keeps coming up. We're not finished by a long shot, but I'm referencing these items to keep you in mind for what's yet to come, because I think this is pretty exciting stuff. Okay, and you've also got Marvel 10 gigabit Ethernet. Nice. Probably 3 items that I like about this motherboard, and only 3. 1, you got 10 gigabit Ethernet. 2, you got Thunderbolt 4. But also, and right here under USB-C, we're going to have to do a separate video about 20 gigabit USB-C. To reiterate, that's what you have with the Generation 2x2. So that's a 20 gigabit USB-C port. So you've got Thunderbolt 4. Let's think about the numbers. Thunderbolt 4, Thunderbolt 3, which is 40 gigabit according to the spec, which is based on PCI Express 3, which is only good for about 31 gigabits. It's just facts the way they are. Why the difference in the reference? It's all about marketing. This is Intel we're talking about. And all this information that we're still going through with the motherboard, the CPU that we've got to look at, and the chipset we've got to look at, this is Intel. Okay, you got 10 gigabit USB-C, you got 20 gigabit USB-C, and you got, to reiterate, 40 gigabit USB-C, which is Thunderbolt 4. And I would expect, because you have Thunderbolt 4, once the driver is updated, and if it's supported for tunneling in the BIOS, that you will then have USB 4. That's my expectation. I haven't seen that, but I'm referencing that because I've seen it on other motherboards. Driver update for that. What gets weird and fascinating is the placement of these ports that we're going to look at and see how this plays out. Because I'm seeing some things on this board I've never seen before, and I had to look at it in other places to figure out if what I was reading was correct, because some of the information to me was confusing. And I like to think I know what I'm doing, but every motherboard's a new journey. It's another animal, and absolutely fascinating. ASUS has set this page where it won't let me scroll to what I want, where I want, so we can look at it. So I'm going to have to hold it, and I can't zoom in on it. If I do, I'll lose my place. What I want to point out on the back I/O panel where it says 1 Thunderbolt 4 port. Yeah, I'll show you where the other one's at here in just a second. 1 USB 2x2 port, also on the back. It's interesting. And then 8 USB 3 ports. 7 of them are USB 3, and 1, to reiterate, is USB-C. So that's your 1, 2, 3 USB-C ports. To reiterate, 1's Thunderbolt on the back, not 2. The other one goes out to the front. 1 2x2 port, which is 20 gigabits. So to reiterate, you're looking at, out the back, 10 gigabit USB-C, 20 gigabit USB-C, and 40 gigabit USB-C. I'm hoping the way I'm explaining this will make it easy to understand. Internal I/O connectors, multiple headers for fans, and multiple power connectors. Storage items, and it shows for an internal connector right there. 1 Thunderbolt 4, 40 gigabit, 1 20 gigabit, which is a 2x2 USB-C, and then of course 1 10 gigabit. And then 2 headers for 4 USB 3 ports, 2 ports per header. And then 2 USB 2 headers, which we still all have a need for. And all this other miscellaneous stuff is going to be referenced when we start looking at the motherboard contents, because first thing you're going to do, we'll go through it when we get into the manual, is do an unboxing, put a camera on it so that way you make sure what you ordered is what you received. And then number 2, you want to inventory all your parts. There's a lot of parts with this motherboard. Inventory everything. You want to make sure nothing's missing, because if it is, it could be a deal breaker. And what the vendor will say, if you ask for parts, they're going to say send the motherboard back and get another one. They don't stock those parts. They stock the motherboards because that's what they sell. Getting parts like it used to be is not like it used to be. So itemize and inventory all that stuff before you get started. You'll see why I had to make a list as we go through this so I can stay on point, because there's a lot of information here. Now, we still got the manual to look at to download. We've only looked at the specs, and I've related to you some of the stuff as we go through those specs just on the tech specs of the website. Okay, we've still got to take a look at the CPU, and the question is about two CPUs, one reference, which is actually two references, but because of the way all this works, I'm going to stick with the question. So what we need to do now is let's go ahead and download the manual. Then I'm going to go look at the CPU, then the chipset. So we'll go over here under support. Then we'll go to manual and document. We do not need the first item. What we need is the user's manual, and we're going to need the BIOS manual. The problem with the BIOS manual, it is generic. It is not specific, so that's going to be somewhat problematic. So looking at the manual for the motherboard, first thing I'm going to do, we'll go to page 3. Now, other items we're looking for in a manual. There's about 5 or 6 things I like to find. Number one, I'd like to see a chipset block diagram. We don't have it, but always look. Number two, we're going to be looking at the specifications because we're looking for consistency, some congruence. Number 3, we're going to need to look at the connectors with shared bandwidth. That's a big deal. Package contents is important because you want to inventory your components. We're not going to look at that right now. Don't need to. We need to look at the motherboard layout. That's extremely important. And we may take a look at the M.2 connectors because that's a big deal. So let's start with the specification summary, which is on page 7. Again, referencing the CPU. We still got that to go take a look at. Chipset, Intel Z690. That was one of the other recurring themes, just in case I hadn't pointed that out. One was commitment to the Intel Z690 chipset. I don't know why. I'm not a fan of it. I'll tell you why in a minute. Number 2, if I haven't reiterated, if you haven't heard it already, was the issue about a workstation for deep learning. We're building a desktop computer. We're not building a workstation. But the price of this motherboard, you can get a workstation motherboard for a whole lot more for a whole lot less money. That's just my reference point. And I'll come back to that in a minute. And to reiterate, 4 DIMMs, this motherboard supports 128 gigs. That point is going to come home again in a few minutes. Now, this, to reiterate, is non-ECC. We're going to go through that as well, because that's another question that came up. Going down to graphics, 2 Thunderbolt 4 ports, supports DisplayPort and Thunderbolt Video Out. The expansion slots, this is usually where we focus on, expansion slots and storage. That information is the same. And to reiterate, the PCI Express bifurcation table, we're going to check that. Okay, so that information is still the same. And storage, that's all still the same. Sometimes information differs. And information through the chipset, CPU, and SATA ports, that's all still the same. Ethernet, same information. And configuration, I think, has a little bit better clarity here. And I can scroll this without it jumping back and forth. Okay, front USB 10 ports. 1 Thunderbolt 4 connector, which is pretty wild. And the 2x2, this is one 20 gigabit USB-C. So reiterate, Thunderbolt 4, which is 40 gigabit USB-C. The generation 2x2, which is 20 gigabit USB-C. And then we have 2 headers for USB 3. That'll give us 4 ports, again out the front. And then 4 USB 2 headers, which we'll need. Audio I'm not concerned about, not part of the questions. And the back panel I/O ports, to reiterate, 1 Thunderbolt 4, which is 40 gigabit, 1 2x2 port, which is 20 gigabit. Okay, here's where it gets interesting. We have 8 USB 3 generation 2 ports. 7 of those are USB 3, and 1 is USB-C. So that 1 USB-C is 10 gigabit. So going backwards, 10 gigabit USB-C, 20 gigabit USB-C, and then 40 gigabit USB-C Thunderbolt 4. How's that? And also the Marvel 10 gigabit. Plenty of fan headers. Not part of the questions. Storage related, we have 3 M.2 connectors and 1 DIMM.2 slot that supports 2 M.2 connectors, which gives us our 5. And to reiterate, 6 SATA ports. 4 are native chipset support that can be used in RAID and can be bootable. And the other 2, to reiterate, are a separate chipset. And then a repetition of the USB where you get a sense of the connectors. First time I read this, I didn't quite get it until I looked at the motherboard. Then it all made sense. And I've never seen that on a motherboard. So actually there's 2 things on this motherboard I've never seen. I've never seen the USB ports and Thunderbolt ports arranged this way. Wherever there's been Thunderbolt, there's always been 2 Thunderbolt ports out the back. The other item that I've come across on this motherboard is the way the M.2 connectors are set out. Two of them are inverted. We'll get to it. It's one of the questions. And that brings up one question, another question. How they handle heat. Good question. Now, so that we can stay on point, first thing we need to do is look at the CPU. Richard is looking at two different CPUs. In his mind, he's thinking one thing about ECC. One processor supports ECC, the other processor does not. But there is more information to be gleaned from this than just that, because the other issue that usually comes up, which is the first requirement, is one CPU has video in it, the other does not. For this motherboard, I think that's going to be relevant, and I'll show you why when we get to it. Everything is like, here's this, we'll get to it. Next. So the first thing we want to look on the CPU about, we're not even looking at cores this time, which of course, that will come up again as it relates to a workstation. You've got a total of 16 cores, 8 performance cores, 8 efficiency cores. So 16 cores, 24 threads. We'll come back to that. Maximum memory supported, 128 gigs. Now, this will support DDR5 4800 or DDR4 3200. Now, for those that are going to ask, you will not see a motherboard that will support both because the pins are different. We've been through SIPs, SIMs, DIMMs, DDR 1, 2, 3, and 4, and DDR was just DDR. But I'm referring to it now as DDR1 looking back. And I've been a fan of all of it, but I'm not a fan of the chipset, and I'm not a fan of DDR5, but that's just me. For those that are having difficulty with memory, I probably ought to tell you now, stick with the QVL for what's on the motherboard. We're going to take a look at PCPartPicker as I bring this information together, because we're still pulling parts together. But I need to go through these two CPUs first. But to reiterate, stick with the QVL. What's going to happen with the memory as you guys are using DDR5, for those that want to do it, it's going to have a BIOS update. And a BIOS update is not just updating the motherboard BIOS, but it may also be updating the microcode in the CPU so that that memory can mesh and work with that CPU. If you get off kilter with that QVL, then my second suggestion would be to go to the manufacturer and ask them, because they'll have a list based on the motherboards they support on any tweaks in timings. Other than that, you'll be on your own to see what other people are doing to tweak that memory to get it set to work the way you want it to. And again, my first suggestion, because we're talking dual channel, I would put in 2 sticks and then build on that and then put in the other 2 sticks. Same thing with the configuration that we get into with the GPU. There's some things you've already predefined that you've decided on. Even though you've asked, I'm still going to tell you, build it simple, build it up, because there's leading, bleeding, cutting, and trailing edge technology. Right now, a lot of stuff that is on this is bleeding edge technology, and I always say let somebody else do the bleeding. You're going to have some BIOS updates. And this brings up other questions that I probably should go ahead and mention now while I'm on the topic, because this has Thunderbolt 4 on the motherboard. When you're looking at BIOS updates, a lot of people think are inclusive. In other words, this BIOS update, you can skip 3 or 4 and you can pick up everything. Well, I'll relate to this the way this works with Gigabyte, and I would expect it works with ASUS the same way until I see otherwise. BIOS updates, and this brings up another question, what about Thunderbolt? I prefer Thunderbolt on a separate add-in card for a lot of reasons, and this is one of them. When you update the BIOS, you're updating the motherboard BIOS, but if you have Thunderbolt built onto the board, you're not only updating the motherboard BIOS, you may be updating the microcode in the CPU, but you may also be updating the firmware for Thunderbolt. So, to reiterate, when you do a BIOS update, because of the issues with the different versions, you want to be stepping through each BIOS update, because each BIOS update updates something different. Not all BIOS updates update everything, so you want to keep them in sequential order. From whenever you get the motherboard, for whatever it says that's on there, when you boot that up or what's on the box, step through each one of those updates. I say that. A lot of people take issue when I say that, but if you had Thunderbolt and Thunderbolt goes away and Thunderbolt can come back, I've had people had to step back through BIOS updates to get Thunderbolt back. So that's why. Keep it simple and make it work. Okay, the next issue we need to look at, more importantly, okay, the DMI and the DMI lanes. That's another name for what Intel calls their lanes that connect the CPU to the chipset. A lot of times, historically, it's been 4 lanes. Now they're using 8, which is good. So anything through the chipset goes through those 8 lanes to talk to the CPU. So you got 2 types of PCI Express resources. You got CPU PCI Express lanes, and you got chipset PCI Express lanes. Anything we do to the CPU is going to be a 16-lane slot or an 8-lane slot. And typically anything through the chipset is going to be 4 lanes or less. Those are lower performing devices. So when you talk about a quad card and you need to bifurcate it, you got to have CPU lanes that can be fully bifurcated to 4x4x4x4 for those 4 drives to get 16 lanes. Otherwise, what you'll have, and I'll bring it up again a little bit later when it comes up, if you wanted to put a quad card on this machine, because it's going to be an 8-lane slot, you can only see 2 drives. And the way I understand from what ASUS says about bifurcation on this board, but I can't see it to show it to you because it's in the BIOS, not in the manual, but it's referenced on the ASUS bifurcation table. To see 2 drives, it looks like bifurcation would be by 8x8, which means the position of the drives would be 1 and 3, not sequential of 1, 2, 3, and 4. 1 and 8. Keep that in mind. So if you were to add a quad card, to reiterate, you'd see 2 drives, not 4. Next. That's why this stuff has to be done the way we're doing it. Now here's the part that I'm most interested in, PCI Express revision. This CPU supports PCI Express 5 and 4, and the maximum number of lanes are 20 lanes. So you take 16 plus the 4, that's how you get your 20. There's only one way to add more lanes to a computer, and that's with a PLX chip. ASUS has had some workstation motherboards. You can take a look at some of the X299 motherboards that were beautiful, brilliant, where they had added a PLX chip to added lanes on the motherboard to add more slots. Okay, the way PLX chips work on a built-in add-in card is for bifurcation. That way you don't have to have motherboard bifurcation, but you're looking at a card that probably costs as much as the motherboard of the CPU. Now, in this case, this motherboard costs more than a workstation motherboard. But with a workstation motherboard, you have more resources, more PCI Express resources, more PCI Express CPU lanes, and more PCI Express chipset lanes. All those details matter. And another key issue on this CPU, as I'm trying to stay on point, there is no reference on this CPU that I can find about ECC RAM. Now this processor, the first one, is the Intel i9 12900KF. What we need to do is now we're going to take a look at the i9 12900K. And going down through the list, 16 cores, 24 threads, 128 gigs, DDR5 or DDR4, 2 channels. 2 channels has been around for a long time. We've gone through dual channel, triple channel, 4 channel or quad channel, and we now have 8 channel. And here we are still using 2 channel with faster memory. Okay, talks about the bandwidth, and right here, ECC memory supported, yes. Okay, I'm going to flip over on this memory specification for the first CPU. Let's look at memory specifications. See if I can zoom in on that. No mention of ECC on the first one. And on this second one, there is ECC memory supported. That was one of Richard's big questions that came up twice. And yes, for a workstation, I would want to have ECC support. Okay, to reiterate, first CPU doesn't support it. Second CPU does. Now what we need to do, again, the motherboard said it doesn't support it, but we need to look at the chipset and see what it supports. All these details matter. So this time we're going to go to PCPartPicker and we're going to choose a motherboard. First thing we'll do is pick according to brand, ASUS. Next thing we'll pick according to chipset, Intel Z690. For a consumer desktop motherboard, this makes sorting a whole lot easier. We have 20 compatible products, and I did a search on the word extreme and there's only one. Okay, before I add this, I'm going to click on it and I'm going to zoom out of this because I want to reference the price on this motherboard right quick. This motherboard is more expensive than a workstation motherboard. It supports 128 gigs of memory, so we're going to add that to the list. I'm going to come back and reference that again. Now we need to go back over here and we can choose a CPU. Okay, from PCPartPicker, and I like the way this lays this out. Once we've set this up and itemized according to core count, very top we have 12,900K. We're looking at the one item that's different than the 12,900KF, which is in the K has graphics, whereas the KF does not. No mention of ECC, but this is going to come up because this is important. And the difference in price, you pay a little bit more for the graphics, but you're also not only getting graphics, you're getting that ECC support. Okay, that's as far as the CPU. Now we need to go look at the chipset, and this is the Intel Z690. All these links will be in the description. And what we want to know, right here under memory specifications, 2 DIMMs, ECC memory supported? No. Now, Richard had asked, and remember recurring themes about a workstation. Again, this is a consumer desktop computer. So on this chipset that I'm not a fan of, you don't have ECC support. So there's no way you're going to get a BIOS update, which is something else Richard asked about. No BIOS update can enable something that doesn't exist. One CPU does support it, one CPU does not. But even though one CPU does and does not, of the 2 things that you benefit, one being also the graphics, you still need that CPU on this motherboard that I'll get to, but you cannot enable ECC support. It doesn't exist. There is not going to be a BIOS update for that, to reiterate. So another cog in the wheel. Now, going back to Richard's questions, that's why I had to do this outline, because if we had read all of his comments, we'd be here for a little while. And to keep me on track, because there's lots of rabbit holes here, and I'm trying to keep this focused on his questions as it relates to this motherboard. Okay, for machine learning, deep learning, we've established there's no ECC RAM support because it doesn't support it in the chipset. Therefore, there will be no BIOS update to support it. It's impossible. It's a feature that's not there. If that feature matters, then I would stop right there. And to reiterate, I'm not a fan of the chipset, and I'm not a fan of PCI Express 5 right now. I think PCI Express 6 is going to iron out the problems we're having with PCI Express 5. That's just my take, because PCI Express 5, for example, now that I tell you this, I'll put up a link to it. Tektronix has testing equipment. There are like 50 different parameters that can be tested with DDR5 to verify and validate that that memory functionally works. So there's a lot of stuff going on because of the increase in speed and bandwidth. So DDR5 is going to have some kinks to iron out, and because you're dealing with bleeding edge technology, be prepared for what's going to happen. There's no way the manufacturers can test everything. That's what we are there for. So you're going to be part of that. You're going to have to accept it. And the first thing a motherboard manufacturer will probably say, if you're having problems, they'll just do RMA and send it back, which is not going to solve the problem when you need a BIOS update. But it depends on how good the silicone is. So as the memory gets better and they get tighter on fixing that issue, we're probably looking at faster memory controllers. But another technology I need to bring up, since you've mentioned deep learning, so that I can stay on topic, and I'll put up a link to this, you might want to look into CXL-SSD technology. That's about 2 to 3 years out, but that will blow the doors off of a lot of stuff that's going on right now for deep learning, artificial intelligence, and machine learning. There's some wicked stuff coming down the pipeline. Micron is doing some stuff, a lot of stuff with it. Samsung is working on it. They're just waiting on the products to come to market to make use of it. Don't want to get any more into that. Next question. Now, of Richard's 10 to 12 questions to tell you where we're at. Right now we're at number 3. And this is the one that has me a bit baffled, because this is somewhat of a consternation, I'll say. We're going to take a look at the M.2 connectors on that motherboard. And you can read what Richard read, what Richard asked me to read. And I'll be interested to get your take on this. Okay, real quick, keep in mind, this motherboard supports 5 M.2 NVMe drives, 5 M.2 NVMe PCI Express drives, 1, 2, and 3, and then on the DIMM card, 2 more. We're looking specifically at 2 of these drives. And remember, other 3 that are on the motherboard, not including the 2 on the DIMM, you've got 1 to the CPU, 2 to the CPU, and you've got number 3 through the chipset. We're going to look at number 2 and number 3. And I hope this reference helps. In the manual, we're going to go to page 27, and we are looking at M.2_1, but we are speaking specifically about M.2_2 and M.2_3. Take a look at the key orientation on these, and take a look at the key orientation on this bottom one. I'll zoom in on that so you can see that a little bit clearer. Up here at the top, and then down here at the bottom. Let me zoom out. Let's read a little further. And on down toward the bottom of this page, I'm going to read this, then we'll go back and look at it again. The M.2 slots for the M.2_2, which is the second slot to the CPU, and M.2_3, which is the one slot on the motherboard through the chipset, are inverted. I've never seen inverted M.2 connectors before. Please flip the module upside down when installing an M.2 to these slots. Let's go back and look at that again. To reiterate, M.2_2 and M.2_3 are inverted right here on the motherboard. These two right there. I have never seen that. So for those of you that have seen our videos about 14 different M.2 NVMe heatsinks on the motherboard, on quad cards, and about dual adapters, and 2 or 3 thermal pads, everything is about heat coming up off the controller. And now we're going to take it and turn it upside down. So how is that going to affect an M.2 drive, whether it's single-sided or double-sided? I don't know. I learned enough about doing all those heatsink tests, and we had somebody else mentioning another new heatsink that's even taller. Tallest I've heard of one yet. Who knows? Separate video. But my question is, how's that going to affect heat transfer? Now, I've read what Phison and MSI have said, that they expect heat to transfer either through the M.2 connector or through the screw that holds it down, which totally blows the way we are working with trying to get heat dissipated up and out. So I'm really curious, for those of you that build this, run the numbers, test it, let us know what kind of results you get. If you put M.2_1 on there as a reference, depending on your setup, and if you can put M.2_2 and M.2_3. Now, to the CPU is going to be faster than through the chipset, but your speed, what I want to know about is the heat. Always this stuff, everything we're talking about, always test and verify. But as a can of worms, or like peeling back an onion, there's still more. We are by no means complete with what we were talking about, but to stay on point with Richard's questions, okay, we are by no means finished with the CPU, and we're going to come back to this issue about the M.2 drives again, but so that I can stay on point with Richard's questions. Next question. Okay, this is question number 4 out of about 10 or 12. I know there's a lot of information. Okay, Richard has stated he wants to put in 2 RTX 3090s to pool the memory via NVLink. Yeah, okay. Remember the first question? 2 slots, 1 M.2 drive, which means 3 resources, and you can only use 2. Richard said he already has the 2 RTX 3090s, so a lot of questions come up with this about the render engine, but that's from our perspective because we talk about content creation and rendering. And we're going to address that as best we can the way Richard has asked it. Yes, technologically, you pool the memory. So you've got 2 slots that are each going to be 8 lanes. And another question comes up as it relates to this, or somebody starts wanting to correct me on this. You got 2 16-lane slots that are PCI Express 5. There's going to be reference to what you're asking that relates to PCI Express 4. And because of that, because of the questions that you're asking, is going to relate to PCI Express 3. So I want to outline that right away. Okay, the first, based on what you've asked. Yes, you pool the memory with NVLink, but it may be easier just to have the 2 cards side by side, depending on the rendering engine you're using and how it works the data bucket. In other words, whatever is in the data bucket is copied to each GPU. So even though you can pool the memory, depending on the render engine and how it's seeing those GPUs, it may be seeing this GPU and this GPU. It may not see those GPUs. So, and I'll put up a couple links with some great information about that. One from Puget Systems that's done a lot of testing about NVLink, but one I believe is into CGI Director that talks about, as you get down to the end of the article, it's worth a read, about how that pooling memory thing works. Depends on your render engine. Now, from my perspective, it's all about video editing, which is only one little bit of all the video engines that do rendering. Back to your first question as it relates to this fourth question. You've already said you're going to put in 2 GPUs, so that wipes out the other resource, which is the M.2 NVMe drive of PCI Express 5. So that connector doesn't exist. So that'll work. Now your next question, and it's interesting, not only the information you're asking, the way you've listed it, but the way I'm trying to categorize this so I can relate this to you guys. You asked number 1 about gaming. You want to be able to do that on the machine as we went down through the list, as you prioritize gaming over video editing. I don't know a thing about gaming. That's not what we do. We build business machines, and we specifically work toward rendering for content creation. So you can game on anything, and you can definitely game on this. But as you do video editing, there's a formula that we work to that we always talk about, and we reference the machine that I've got in front of me. Okay, to reiterate, this machine in front of me is the high-end desktop. So you've got a desktop computer that you're building. You're talking about a workstation, which is above a high-end desktop. And this machine, to reiterate, is the Gigabyte TRX40 Designaire. And this is what we were recommending based on PCI Express resources for PCI Express CPU lanes and PCI Express chipset lanes. And we sort those out as people want to add storage for one of these quad cards. With what you want to do, the quad card is out, that's going to come back. But as it relates to video editing, the formula, number 1, CPU cores times 4 equals RAM. Number 2, CPU core count equals video RAM. So you can kind of see where that goes. And I still recommend one GPU, keep it simple. But with multiple GPUs, to reiterate, when you build a machine, first of all, one GPU, get configured, get that up and running. Then you can do your BIOS settings, get everything set like it needs to be in the unified EFI. Then come back and set in your second GPU. Once that's up, functional, and running, then go in and do your NVLink if you choose to do that. So that's the formula for the Adobe After Effects multi-frame rendering CPU optimization formula. It's phenomenal. Now, I don't use Adobe software, but that formula is the best anybody's had. And if you'll notice in that formula, it talks about amounts, about quantity. There's nothing about speed. It's all about quantity. Number of CPU cores, the amount of RAM you're going to have. And remember, this motherboard supports how much RAM? Dual channel, 128 gigs. Because this is going to come up again with another question you've asked. Okay, question number 6. You asked about drive management. And we've kind of gone through this. I'll go through it again. You got 6 SATA ports, 4 can be in RAID, 2 cannot. We've been through that. And then you also mentioned no HyperCard, which is good because according to the bifurcation chart, it can be supported, but only 2 drives will be seen, as I've already stated. But to reiterate that fact, 2 drives. 4 SATA ports for RAID 5 and no NVMe RAID. Because of your 5 connectors, you've eliminated 1. You've only got 1 left to the CPU and the other 3 are through the chipset. I would, if you're going to RAID the NVMe, I would maybe RAID those 2 on the DIMM card, but I don't know because of the interconnect being in a different location that I would RAID all 3 of those that are on the chipset. So you would get RAID 0 or RAID 1, but you would not get RAID 5 on NVMe because I wouldn't take that 4th drive that's to the CPU that will be the fastest. I wouldn't RAID those like that. I would keep CPU to CPU and I'd keep chipset to chipset. But that's just my preference. You asked. Now your next question, NAS and RAID. Okay, network attached storage. We've talked some about that. We're going to do a separate video on that. But as it relates to your question on this motherboard, this would be a great machine that you're building because it's a desktop computer for NAS. I like NAS as a technology and I like NAS as a concept, but I don't like the implementation. If someone said they wanted to do NAS, which is network attached storage to reiterate, I would say look at something like QNAP for an AMD EPYC server. That would make a wicked network attached storage device, but that's for copious amounts of data. For the NAS you're trying to build, a desktop computer is easy to access. Share a letter on the network, you're in business. Easy to upgrade, easy to fix, easy to maintain. But I would use a less expensive motherboard to get all those SATA ports. And RAID 5, which relates to another question or comment that you have about the case you're using, since there's no hot swap, no hot plug, there's no way to do which is one of the benefits of RAID 5. But you'll get with RAID, first it's about speed and capacity. The next it's about data integrity or data redundancy. So you'll get that with RAID 5 on SATA drives if you want to go that way. Now this brings us to the case. I think a picture's worth 1,000 words. Let's take a look at the case because now this helps me to understand your priorities. You're looking at a Thermaltake 900 case. And the primary reason you said you were looking at that case, it's a beautiful case, but that is, and I got to say this, form over function. It's a pretty case. Richard's looking at this case because he wants to put those 2 GPUs in a vertical mount. So as we talk about how all this stuff comes together and relates, one side we look at function. Function is what we're all about. All this stuff about form that has nothing to do with function, to me, is extemporaneous. You want to do RAID 5, but you don't have hot swap. You want to do video editing, but you don't have hot swap. Okay, that again shows that you prioritize gaming over video editing. And because you want to have those two GPUs up vertically mounted, we've got some separate videos where we've gone through about vertically mounting with a bracket and with two different PCI Express 4.0 cables. Okay, your motherboard supports PCI Express 5. Your two GPUs right now are going to be PCI Express 4. Our experience with PCI Express 4, because of the elongated cables to try to do something vertically mounted, what you're going to get into is you're probably going to have to slow those down to PCI Express 3. I told you this will come back around. Because of the cables we've tried, you're going to get a BSOD. Try one video card at a time on the motherboard and then try them on the cable one at a time separately. In the ASUS, there's going to be a setting on the BIOS where you can slow down the PCI Express bus to do that. Even though the cables to read or write say they're PCI Express 4, it didn't work for us. And we were trying it with quad cards because we wanted to get the quad card up. We were doing an emissivity test, but we've done videos on all that and I've described all that. So what you want to do is all about form, nothing about function. And I understand and I get that. But I think you're going to be asking for trouble because from what we can tell, based on as we go faster, not only are we having more heat, but we're having issues with timing to get that signal where it needs to be, and we expect everything to work. I expect there's going to be some smarts on these cables. In other words, the cables for the interconnect to get an extension cable can't be like extension cables we've had in the past. It's going to have to be something more like an NVLink type cable where there's some redrivers, where there's some technology, where there's some smarts that helps that signal maintain integrity. So pretty case, but pretty case. And we'll also have a link up into Amazon for all this stuff we're talking about for those who want to double check it. Okay, your next comment or question that came up, and I believe we're at point number 9, was about liquid cooling. I have my own take on liquid cooling, and I'm a bit jaded on my view about liquid cooling. Again, to reiterate, we're all about function, not over form. And I think a lot of people that are doing liquid cooling, they say performance, which I can't see justifies the expense, and I can't see justifies the risk of getting liquid on a motherboard. Now, my reference for that, for those of you that remember, and this has been back 97 or 98, somewhere in that time frame, there was a time when the capacitor used electrolytes. The caps were blowing off the capacitors, and that clear white jelly-like substance was oozing out on the motherboards, and when that fluid hit those motherboards, that was it. One of our members that came to the live meetings was replacing those capacitors. Okay, things have changed, but I learned enough with that I'm afraid of liquid. Now, I have built one computer that had a liquid cooler in it, and it worked, but that was like building a Swiss watch, getting everything in a case. So I understand, looking at this case, why you want to do liquid cooling. I think it'll look pretty, but I don't know if it's worth the time and the trouble to make something look pretty. But again, you've built a desktop computer. This is not a workstation. Okay, and one of the other themes that came up that you pointed out puts us at point number 10, which was about ECC support. So another theme, no ECC. Good idea, but you've not built a workstation and not really a video editing platform, although it can. You've built a popsicle, a candy stick. You're building a look pretty machine. It will function, but it's not going to get all the function for the money. I'll come back to that in a minute. This brings us to comment 11. We still got number 12 to get into because there's some really good stuff here. Okay, you stated that you're committed to the Z690 chipset. You also stated that Workstation Intel Learning Machine, because we had some conversations that if you want a workstation, my recommendation above this, which is a high-end desktop, and you're building a desktop machine, would be to jump over this for a workstation, which is a WRX80. That's the best bang for the buck, and that's what we advocate. But you said you wanted to be able to use Intel's machine learning. Okay, to use those resources from Intel, that stuff is designed for a Xeon. That's a workstation. You're not even looking at that. And there's going to be some new stuff with a Xeon, but it's not there yet. So I don't really know. I get a mixed signal. And yes, even though that's designed for a Xeon, you can do that on an i9. But I'm just referencing where a workstation sits, because this is probably one of the most important aspects of all the questions you've asked that relates to this motherboard and this build. You've asked about Windows Pro for workstations. We referenced this at one of the live meetings back when we first learned about Windows Pro for Workstations back in 2017. Okay, from my perspective, there are 3 benefits for Windows Pro for Workstations. So I'm going to reference those 3 benefits, and let's see how that measures up with what you're building. And I'll put up a link that I'm going to show you from Microsoft. Now this link from Microsoft is referenced from August the 10th of 2017. And another link from Microsoft that's from December the 15th of 2017. And here's a chart that I want to show you. Okay, Windows 10 Home, Windows 10 Pro, Windows 10 Pro for Workstations, and then Windows 10 Enterprise. Yes, we used to have quite a few that were using Windows 10 Enterprise. Separate topic. Okay, to reiterate, Windows 10 Home, Windows 10 Pro, and Windows 10 Pro for Workstations. The maximum number of CPUs, 2, or 4. And how many CPUs does your motherboard support? It supports 1. You get my drift? Maximum number of cores, 256 all across the board. Maximum number of RAM, 2 terabytes, or 6 terabytes. And how much RAM does your motherboard support? 128 gigs. Okay, so right now you've got 1 CPU core, you got 128 gigs. What else we got? Here's a list of the 3 things I see. Now, the way Microsoft has its information listed is a little bit different, and there are some other benefits. But from our perspective and perception, the 3 benefits. Up to 4 CPUs and 6 terabytes of RAM, we've established that. Number 2, support for persistent memory. Intel Optane is a type of persistent memory, but the persistent memory that is supported for Windows Pro for Workstations is NVDIMM-N. I'll put up a link to share some information on that. And number 3, probably the most important aspect, is the REFS, which is the Resilient File System. Now, of those 3 benefits, on your motherboard, if you install Windows Pro for Workstations, which is licensed according to the CPU, it's a lot more expensive than Windows Pro. You can pick up a Windows 10 Pro license for maybe $10, $15. Less if you know how to buy it right, and it's a legitimate copy, so I won't get into that separate discussion. But for the 3 things that you could benefit from with Windows Pro for Workstations, only one, the Resilient File System, I don't see, unless you're, again, going to be like I referenced, an AMD EPYC server for a NAS, that would be benefiting copious amounts of data. Now, there's a lot of other aspects about this motherboard that we could get into, but as we went through these 10 to 12 talking points from Richard about his questions as it related to that motherboard with everything he was doing, all this information, bringing this all together, I had to read through this stuff several times. I didn't even get into stuff as totally as I usually do about shared bandwidth so that we could stay on track. And I hope you understand why we had to do a video of this. So, welcome. My name is Gil Boyd. I want to thank you for joining us. This is BuildOrBuy. We'll look forward to seeing you next video. We're out.